The blue sky is reflected in the seas and oceans, which are tinted in different shades by everything that flows in the water. Either by the dust washed away from the mainland, various salts, or microscopic live plankton. The rivers swallowing this and that on their way through the mainland appear in shades of green, yellow, and brown. But many of them are born in places where water is snow white, as it comes from glaciers high in the mountains. And just a few kilometers higher, we'll start looking for water in space. So, we are just about to step into space. Below us is the troposphere, where the phenomenon called weather occurs, and above us, the stratosphere. We are now whizzing along through thin air, more than 12 kilometers above the Earth's surface. Why so high? Well, when observing the universe, a telescope comes in handy, and when searching for water, an infrared one. This is because the presence of water molecules is revealed by their characteristic infrared radiation, invisible to the human eye. But there are so many water molecules in the low Earth's atmosphere that searching for water in space from the ground would be like throwing a telescope into a pool. The solution to this problem is called SOFIA, or a winged infrared observatory. You simply stick a telescope into a specially modified Boeing and fly it up where there's so little air and so few water molecules that you have a clear view. And then you get surprised. Why? Because when you focus on the nearest celestial object, the moon, surprisingly, you find water. What's so special about this? You'll find out once you take a little tour of the lunar surface. Well, it's craters on the left, craters on the right, and craters in front of you too. Then also lunar dust, but it's mainly craters, isn't it? If we add the daytime temperatures of more than 100 degrees Celsius and no atmosphere, it doesn't look like there's a lot of water on the moon. It's true that in 1971, much to everyone's surprise, the Apollo 14 crew detected some water at their landing site. But it turned out to be, how to say it politely, let's just say the landing module had a leaky radiator. But almost a half a century later, the SOFIA Boeing Observatory discovered that, against all odds, there is water on the moon. And even on the sunlit surface when nobody would expect it. For example, in the giant crater of Clavius. It's just perfectly hidden in the form of microscopic ice particles dispersed in porous moon rock. From 1 cubic meter, a maximum of 1 small glass of water. For the inhabitants of the water world, it's probably very little, but for future lunar expeditions, it's quite a bit. And it's not just about quenching thirst. A molecule of water is also 1 oxygen atom and 2 hydrogen atoms, of which we can make great use when staying on the moon. The oxygen for breathing, and the hydrogen, for example, for rocket engines or fuel cells producing electricity. If there are any enemies of water in the solar system, they are heat and light. They cause water to evaporate or even its molecules to break down into atoms. It's the case when the light is ultraviolet radiation from the sun. By the way, we really won't be searching for water on this glowing ball heated to more than 5,000 degrees Celsius.
Oh no, mommy! My hand.
Speaking about light and heat, the most exposed world of the solar system is undoubtedly Mercury, the closest planet to the Sun. This little rocky body covered with craters is sort of the yin and yang of our planetary system. The temperature on the planet's hemisphere facing the Sun can easily exceed 400 degrees Celsius. Moreover, its surface is constantly lashed by an intensive solar wind, which is a stream of various particles spewed into space by the Sun. On the other hand, Mercury's dark side gets very cold, and the temperature can drop down to minus 200 degrees Celsius. But as Mercury rotates, the border between light and dark keeps moving. It seems there's no escape from the scorching sun. Not quite. With a simple trick, we'll highlight the areas where the sun never shines. The everlasting shade falls on the bottoms of the craters in the polar areas. So, if we are to search for water on Mercury, it will be right there. Unsurprisingly, it was these areas that the messenger water was found there in the form of stone-frozen ice. But it's far from extraordinary. The same is true for the polar areas of our moon. The Moon and Mercury are bodies playing with open cards from the very beginning. It takes just a few glances from their orbits to know what to expect down there. But there are much more sophisticated card players in the solar system. The planets that don't reveal their cards when it's their turn are Earth and Venus. And while Earth is covered with a rather see-through cloudy veil, Venus wears a heavy-duty overall in the form of its completely opaque atmosphere. The first to find the courage to peep into it were the Soviet space engineers in the 1960s. However, just remotely, through the series of even at that time, it was about searching for water. Venus was then pictured as a pleasant tropical world with warm oceans and a thick atmosphere saturated with water vapor. Simply a place where you'd like to take your kids on holiday. And the reality? In one word, burning. Venera Space Probe number 7 could confirm that as it received a really warm welcome. It all started upon entering the atmosphere, which consists of unbreathable carbon dioxide with acrid and toxic sulfur oxides. At an altitude of 100 kilometers above its surface, Venera was showered with sulfuric acid coming out of vast yellow-white clouds. At the same time, it was being crushed more and more from all sides by the thick and hot atmosphere.
Very hot.
But the probe couldn't rest, even after its successful landing. It was like landing on a hot plate heated up to almost 500 degrees Celsius. But Venera 7 didn't give up, trying to withstand Venus for an incredible 23 minutes. Thanks to it, we already know that Venus is not only the hottest, but also the driest planet in the solar system. But actually, very probably when it was born, there's every indication that between 3 and 4 billion years ago, the Venusian atmosphere was rich in volcanic gases and water vapor. That's why it was soon affected by the greenhouse effect. In other words, it started overheating heavily. The consequences were catastrophic. All the water evaporated. Most of it was dissociated from the sun and in the end escaped into interplanetary space. One of the unique water worlds. At this moment, of course, you may ask whether there's any water on the other planetary neighbor of Earth, on Mars. If Venus is a red-hot lady, then Mars can be described as a cool and sort of monotonous companion. Lost in the metaphors? Okay, let's put it another way. Mars orbits the Sun about 1.5 times further away than Earth, so it's noticeably colder there. On average, about -60 degrees Celsius. Its monotonous character is connected with its desert surface, covering the... We are sure that this planet was also chemically like this. How can we dare to claim this? You can already see the evidence when orbiting Mars. It was there where the space probe cameras spotted the dry riverbeds, dozens of kilometers wide and thousands of kilometers long, crossing the desert landscape in many places. The amount of water rushing in them at some time in the past must have been enormous. Maybe there was a vast ocean, more than 1.5 kilometers deep, on the surface of Mars. Its waters then washed the foothills of the giant volcano of Olympus Mons, forming its final shape. But why hasn't Mars remained a freshwater world and instead turned into a frozen wasteland of sand? Where have all the huge rivers, seas, and oceans gone? We'll find the clue in the Martian polar areas. Their white color is nothing else but a large crust, partly made of water ice, still growing and evaporating with unfailing regularity, according to the changing of the seasons on Mars. Puzzle. We need some sort of in-depth research to get much deeper under the planet's skin. For example, using the rover Perseverance, also fitted with its own drone, which landed on Mars on February the 18th, 2021, in the vicinity of a crater aptly named Jezero, which in most Slavic languages means lake. And what's so extraordinary about digging into the surface of Mars? A freezing message popping out as soon as you push off the thin surface layer of ochre sand. At almost every step under the surface of Mars, you'll find a mixture of water ice and rock. Unlike scorching Venus, the water on Mars hasn't evaporated, but most of it has probably soaked into the ground and frozen to stone thanks to very low temperatures. Why so, we can still only guess. It may be connected with some dramatic weather changes. Moreover, Mars as a tiny planet could not keep its atmosphere, which would have protected. But whatever it was, one thing is for certain. After the solar system was born, more than 4.5 billion years ago, water was a typical feature for Mercury, Venus, Earth, and Mars too. But where did it come from? The approaching body is called Phobos, and together with similar-looking Deimos, is one of the 2 tiny moons of Mars. These rocks coloured with the dust of the Martian atmosphere were once absolutely ordinary asteroids, like billions of others in the solar system. By coincidence, they were caught by the gravitational arms of Mars. Actually, typical asteroids thanks to the robotic explorers, which have even landed on some asteroids. So, what are they like? Noticeably less colourful, and also not so close to Mars. They orbit the Sun a little further away, between the orbits of Mars and Jupiter. This interplanetary rubble is the unused building material of which the planets were formed by accretion a long time ago. And a considerable amount of the water we've got on Earth now was brought by asteroids. Don't think you can squeeze asteroids like a sponge. The water there is dispersed like in moon rock. However, at least in one case you could succeed. This case is called Ceres, and with a diameter of nearly 1,000 kilometers, it's the largest of all the asteroids. Actually, it's so big that astronomers have reclassified it as a dwarf planet. But don't worry about that now. See that huge crater? So sharpen your eyes and look for bright spots in its center. Do you see them? So, tell me what you think they are. Water ice? Wrong. Sodium carbonate. You didn't recognize that? Okay, I'll stop teasing you. This bright whitish material is the salt deposits left behind by water springing from the inside of Ceres to its surface. The water has evaporated, but the salt has remained. Moreover, it happened quite recently, about 2 million years ago. If we shrunk the history of Ceres down to 1 century, it would be just 16 days ago. The interior of Ceres may still today be hiding vast reservoirs of salt water seeping to its surface here and there. Enough talk. We have to catch another flight. It's called Juno and will be here in no time because it's whizzing through space at a speed of 4 million kilometers per hour.
4 million kilometers per hour and this will go very fast and this was 4 million kilometers per hour.
On board Juno, we've just crossed the border. It's an imaginary border between worlds. A border between dwarfs and giants. Between light and dark. Between heat and cold. We've arrived in the realm of the gas giants. But beware the largest of them, gigantic Jupiter. Most importantly, don't slow down, or you'll be mercilessly pulled down and swallowed up in no time. Exactly, swallowed up. Don't get deceived by its appearance. Its stormy atmosphere, filled with a number of enormous vortexes, smoothly changes into a deep ocean, but of liquid hydrogen. You just can't land on this planet, only dive into it. There's no surface there. And water? It's present on this planet, only in a homeopathic amount, as part of some of Jupiter's clouds. However, although it's just a drop of water in the ocean of hydrogen, it lets us know about it really loudly. Because inside the white clouds of ice crystals, lightning and thunder are formed 100 times stronger than on Earth. But also, Jupiter's vicinity, seized by organized chaos, is worth exploring. What else to call the swarm of Jupiter's almost 80 moons, the orbits of which you're just looking at, are worth visiting. But the crater... Grey Ganymede, with its strange fragmented surface, looks about the same. And what about the colourful moon of Io? Well, it's anything else but a water world. Its core, heated by the tidal forces of the planet, produces hot lava rather than water. Actually, it's one of the driest places in the solar system. The one left, Europa, whose surface looks like wrinkled light ice. Bingo! With a little exaggeration, we could call it a giant ice rink, because from a global point of view, Europa's got the smoothest surface of any known objects in the solar system. And lots of cracks separating giant ice flows indicate that this frozen crust is still working. From time to time, it probably cracks and splits apart to join and close up later again. Does it mean there's water, liquid water, under the ice of Europa too? Definitely. The measurements of Europa's magnetic field indicate that there's a giant ocean of salt water under its ice crust, at least 100 kilometers deep. Do you know what that means? That Europa's got more liquid water than us here on Earth. And if there's liquid water, there might be some little creatures too. But this is really thin ice to skate on. That's probably why Europa is so popular with astronomers, and within 1 decade will surely earn its own space probe, which will drill deep into its frozen surface. To put things straight, we have to say that similar water surprises are likely to be hidden under the ice crusts of Ganymede and Callisto too. Anyway, frozen definitely doesn't mean stiff. You'll see for yourself soon when we visit neighboring Saturn, where water ice is an unexpectedly lively entity. There's clear evidence right in front of your eyes. Myriads of tiny ice particles are constantly but remarkably arranged, moving around the planet. Yes, the fascinating rings of Saturn are nothing less than a cocktail of crushed ice, delicately flavored with silicate dust. Kilometers, they are only 10 meters thick.
Hey, what did you say that word? What? I think you said one word, right? Shh. Huh? I said
Where did they come from? Their structure indicates they may have formed from a smaller ice moon that broke apart. For example, a moon like Saturn's Enceladus. It could easily be called a cousin of Jupiter's Europa. It also presents an ice show, but a partially thawed one. Just look carefully. While some places are scarred with deep craters, others look rather facelifted. And just a bit further away, the surface is wrinkled with various cracks, depressions, or zigzagging deformations. In fact, Enceladus is pulsing with life. Well, not literally, but never say never, because if there's running water, you know. Oh yes, running water. Similar to Europa, there's an ocean of liquid water hidden under the ice crust of Enceladus.
I'm going to sit here.
But while on Europa there's no direct evidence, on Enceladus its effects are more than obvious. We just need to look at Enceladus in the right light, or rather, against the light. Then you'll see the mighty geysers spewing thousands of liters of liquid water on the surface of Enceladus from the cracks in its ice crust. But in the vacuum of space, the whirls of water drops immediately turn into clouds of tiny ice crystals. This process is generally known as cryovolcanism. Part of them escape into space and supply the material to one of the delicate rings of Saturn, and the others literally snow back onto the surface of Enceladus, making it one of the whitest places in the solar system. But what heats the core of Enceladus to make the ice thaw and the hot water spew out? Gravitation. Saturn, as well as some of its moons, literally needs Enceladus, making its core extremely hot. After all, this is the reason why there's a liquid ocean on Jupiter's Europa too. But as for the whims of the weather, we have to mention another of Saturn's moons, Titan, surrounded by a thick orange atmosphere. If we looked under it, we would find it's both snowing and raining on Titan. There are streams and rivers, and its surface is formed by shallow lakes and even seas. And all in spite of the temperature dropping down to minus 180 degrees Celsius. Because it isn't water that rains on the surface of Titan, but methane. Well, water doesn't always play first fiddle. There are worlds where its role was successfully taken over by different substances. The last places to explore while searching for water are the planetary suburbs. The area where the furthest planets, Uranus and Neptune, orbit the Sun. Not Earth, but these two are the true blue planets. But these seemingly water worlds are far from what they appear to be. Yes, water is definitely not unusual there, but it's hidden much deeper as one of the many constituent elements of their massive hydrogen envelopes. The blue colour of both planets is caused by a completely different substance which you wouldn't like to swim in. Gaseous methane dispersed in the atmosphere. For water, we have to look somewhere else. Fortunately, just around the corner. But it will be a rather freezing experience. For now, the view of the object we're heading towards is obscured by one of its 5 moons. Our destination is the furthermost large body that our interplanetary space probes have reached so far, dwarf planet Pluto, or the realm of ice. Would you like some nitrogen ice? Or would you prefer some methane ice instead? Or some rather refreshing ammonia ice laced with carbon monoxide? Or just some traditional water ice? Just take your pick. Here, different kinds of ice form high mountains, vast plains, and rolling windswept dunes. But the most interesting are the winding cracks. They indicate that Pluto was born with a vast underground ocean of liquid water, which since then has been slowly freezing solid for billions of years. The expanding ice literally tears the surface of Pluto apart, while the water springing out facelifts it from time to time. It seems incredible, but water, even the liquid one, also controls the frost-dominated areas with temperatures of minus 230 degrees Celsius. By the way, did you know that water is by far one of the most frequent interplanetary travelers? For water, space probes are no match. Now we're going to get closer to one of such traveling space oases. And with a bit of luck, we can come back home together with it. There's every indication it's heading in the right direction, back to the sun. I think so because it's obviously being brought to life and it's warming up. Can you see the jets on its sides? And that's just the beginning. So, do you know who will take us all home? Maybe we need a bit bigger distance. Oh, that's probably too much. Now we'll have to search half of the solar system. But don't worry, our guide will sooner or later appear, despite the fact it's just 10 kilometers in diameter. We just need a bit of patience and enough warming sunlight. Ah, I think we've caught it. Our companion on the way to Earth will be a comet. from now on, we won't see its nucleus that we met just a while ago. The sunlight has warmed it up enough for it to start evaporating fiercely, and it has been swallowed up by the cloud of gas and dust flying dozens of kilometers behind the comet. Of course, after all, comets are made of water too. More precisely, of water ice. Well, at least until they start sunbathing. The return of such a long-haired star bears something symbolic, because comets, of which there may be up to trillions, represent the substance that was left here after the formation of the solar system. In fact, the oldest water we've got here has for billions of years been stored somewhere in the dark, far from the orbit of Neptune.